The last two problems we're going to look at are going to tie in everything that we've seen so far with power series. And what we're going to do is we're going to use a power series to be able to approximate the value of some not so nice sort of function at a specific value. So let's take a look at a pretty easy one to start. So we have this e to the 0.1, all right? And we know 0.1 is pretty close to 0. So one of the things you might want to do is start by looking at the value and saying, okay, well, the function could be e to the x, where a is equal to 0, all right? And then when we actually get the value of the polynomial, then we can just plug in where x is going to be 0.1 for us. Okay, so we have to figure out a Taylor polynomial with degree 3, and then we're going to figure out what the error is, okay, by approximating the exact value in a calculator. Okay, so let's get to it. Let's find a third degree Taylor polynomial. Okay, we're going to use the same method that we did just before. So n is 0, 1, 2, and 3. This one's going to be really easy because we're just going to find the nth derivative at x. Okay, so remember, we always start off with the original function, which is e to the x. And guess what's really nice about this? Every time that we find the derivative of e to the x, well, we get e to the x. Last thing we're going to do is we're going to find the nth derivative at a equals 0. All right. So this is going to be e to the 0, which is 1. This is e to the 0, which is 1. This is e to the 0, which is 1. And then surprisingly, this is e to the 0, which is 1. All right. So to find our third degree Taylor polynomial, okay, this is going to be our formula. I'm just going to call that p sub 3 of x. So that's f at a plus f prime at a, x minus a, plus f double prime at a, divided by 2 factorial, x minus a square. And then finally, we have a third derivative at a, divided by 3 factorial, x minus a cubed. All right, now remember, a is going to be equal to 0 for us, right? And it looks like that f prime, f double prime, and f triple prime, or third derivative, they're all equal to 1. Okay, we can see that. So let's just substitute everything back in and find P3. So P3 is going to be equal to 1, which is our f at a, plus 1 x minus 0, plus 1 over 2 x minus 0 square, plus 1 over 6, okay, and that's 3 factorial, 1 times 2 times 3, which is 6, and then x minus 0 cubed. All right, if I simplify that, P3 is really nice and easy. That's going to be 1 plus x plus a half x squared plus a 6x cubed. All right, so that's going to be our function to approximate the value of e to the x around x equals 0 or a equals 0. Okay, so if we're in the neighborhood of a equals 0, we should get a pretty good approximation. Okay, so now we're going to approximate the given quantity, and we're just going to substitute 0.1 back in for x. Okay, so this is p. I'm going to call this p sub 3 of x. Okay, so p sub 3 at 0.1 is going to be equal to 1 plus 0.1 plus a half of 0.1 square plus a sixth of 0.1 cube. All right, so let's approximate that, and that's going to give us the answer to part I. Okay, so if I go on my calculator, I'm going to go back to graphing calculator. Okay, and so we have 1 plus, and again, I'm just substituting back in right here. Okay, so 1 plus 0.1 plus a half of 0.1 square plus a sixth of 0.1 to the third. Okay, so that gives me 1.1051. Okay, so I'm just going to write it out to a whole bunch of decimal places. All right, So 1.05, or 1.105, excuse me. It keeps going away whenever I try to write on the screen, so apologies. So 1.105, 166,667. All right. Now that is the approximation, okay, for P3. So that's actually going to be part A's answer, okay, approximate the given quantity. All right, so this is for A. Now for B, we want to find the absolute error, which is going to be the absolute value of what we just got for P3 of X minus E to the 0.1, okay? So what might be helpful for us is to find E to the 0.1 in our calculator and then subtract them, okay? So if I find EXP of 1, we'll erase all this stuff, 0.1, excuse me, we get 1.10517. All right. That's actually pretty close to what we got. Okay. So I'm going to say that just so that way we know, e to the 0.1 is approximately 1.105 170,918. Okay, so that's not, I mean, that's kind of helpful, but you can see that we're pretty close. I mean, we go out to the 10,000ths place, all right, and we're still accurate. Okay, in fact, if I wanted to round to the 100,000ths place with that 66667, then I could go ahead and probably be a little bit more accurate. Okay, so what I'm going to do is I'm going to subtract these in my calculator. Okay, so over here, let me clear this out, and I'm just going to take the absolute value of 1.105166667 minus exp, all right, of 1, and there we are. So it gives us an error of 4.25 times 10 to the negative 6. Okay, so that's going to be 4.25 1 times 10 to the negative 6. Okay, a lot of people would say that's a pretty small number, okay? And I would agree, all right? Now that's only going out to a third degree polynomial. If we wanted it to be even more accurate, then we could go out to like a fifth or a seventh or something like that, okay? So keep in mind that these are pretty cool ways for us to be able to approximate these sorts of numbers when we don't necessarily have a calculator. And if we really wanted to, we could do all of this by hand, and it wouldn't be too terrible to be able to do this by hand. Okay, it'd probably take us a couple minutes, but it's better than trying to figure out what the original value is at to the 0.1 power. Okay, all right. So we have one more example after this one. Probably be a trigonometric instead of an exponential, and then we'll be done with our introduction to power series.